Hello, and welcome back to another computer science video. Today I want to cover two topics to finish out our unit on classes and objects, and those topics are scope and access and the this keyword. So let's start with scope and access. Scope and access are properties of variables, any and all variables in Java, and they refer to when and where variables can be used. So access is something we've seen before, and it's referring to the public versus private distinction, where private variables are only accessible within a class or object, and public variables are accessible anywhere that you have the code. Scope is sort of a new topic, though you may have seen the effects of it already, where scope refers to how long the variable is accessible before it is collected by garbage and the reference is deleted. I don't know if that makes sense yet, but we'll see examples of this as we talk through the variables and see a sort of larger example. So the first thing I wanted to do is talk through the 5 types of variables in Java. And by type, I don't mean int, double, boolean, but I mean the types in terms of scope and access and what and how they work. The first type of variable we have is a local variable. Local variables are the variables we've used most often up until now, and they're variables that are declared within a method. So if I have a method, any sort of method, and inside that method I say int x equals 6, well, that means x is a local variable. Local variables can be primitive, like ints or doubles and booleans, or they can be reference data, like points or scanners. They're all local variables if they're declared inside of a method. Local variables are accessible only within the method they are declared. Their scope is only that method, and in any other method you cannot access that variable. If I have one method and I say int x equals 6, and in another method I try to do some math with that x, it just won't work. It won't recognize that variable. Now let's get into a little bit more of a complicated type of variable. This is parameters, and I split parameters into actual parameters and formal parameters. So I have an example here that you should look at for a second. This is our circle constructor, which takes a point p and an int r as parameters. And then below this, I've shown an example of using this circle constructor, where I've created a point at 1, 2, a radius of 3, and then I sent in that point and radius to the circle constructor. So now, what do I mean when I say actual and formal parameters? Well, actual parameters are the values that I send in. In this case, this point and rad, which I have created just above it. The actual parameters are the values that I've sent into the constructors. On the other hand, the formal parameters are these p and r, the variables that take on copies of this value and I can use in my constructor. Why is this distinction important, and how does this exactly work? Well, what happens, let's start with radius. Radius is assigned to 3, or I'm sorry, rad is assigned to 3, and then I pass in rad into my constructor. The compiler sees this, it makes a copy of that value 3, and it assigns that to a new place in memory, which is r. So now I really have a variable rad, which has the value 3, and a variable r that has the value 3, that are two different variables, but just happen to have the same value. Point, on the other hand, works a little bit differently. Here I've made a new point with a reference called point. This name point points to a point object 1, 2. This actual parameter point is sent in, and the value of point is assigned to the formal parameter p. In this case, since it's reference data, all that happens is p is going to point to the same object 1, 2. So now p is an alias, it's a reference to the exact same object as point. The actual and formal parameters both point to the same thing, and then I set that to center. In terms of scope and access, both actual and formal parameters act as local variables. So this point p is a local variable to this constructor, and I cannot refer to it outside of the constructor. No other method knows what p is, you cannot refer to it. Similarly with this point, wherever this chunk of code is held, that's the only place you can refer to point. All right, 2 more types of variables are now associated with classes. We have instance variables. Instance variables are associated with an object. For instance, they're associated with a specific account or a specific circle or a specific card, and they're accessible only to that object but they are accessible anywhere inside that object. So if my card has a rank and a suit, anywhere in the card class I can access that rank and the rank and suit associated with a specific object. In Java, these variables are always private. By convention, whenever we want to access or change them, we have to use getters and setters to do so. On the other hand, static variables, and this is a distinction I talked about in the previous video, are not associated with an object. They're associated with the class as a whole, but they can also be accessed by any method in an object of that class, including static methods, which could not access instance variables. Static variables can be public or private, and this is the distinction we were making with constants versus class variables, and whether they should be public or private. Note here that in instance variables and static variables, I discussed public versus private, whereas for the top three I didn't. Instance variables and static variables are the only two types of variables that we can use the public or private modifiers for. For instance, if I tried to say public int radius rad equals 3, I would be able to throw an error because this is not an instance or static variable. It doesn't make sense to say whether the rad is a public variable because it can't be accessed anywhere else anyway. The scope of it doesn't allow it to be public. Let's look at a big example in the account class and talk about what variables are which type and where they're accessible. So here I have our public class account. Take a second to look through this and see if it makes sense. It should be very similar to examples we've seen before. At the top of account, I have two instance variables, balance and account ID. These are private variables because all instance variables are private that are associated with a specific object and represent that object's balance and account number. These variables can be accessed anywhere inside of the account class and are accessed anywhere, but not anywhere else because they're private. Below that, we have a private static variable number of accounts. This is a static variable, so can't be accessed inside of non-static methods. Sorry, can be accessed inside of non-static methods as well as static methods. But it is private, so it cannot be accessed outside of the account class. These two variables can only be accessed inside of non-static methods. This variable can be accessed inside of any method. Now we get to the constructor and method. This constructor takes as a parameter, a formal parameter, new balance. It sets balance, the instance variable, equal to that new balance. It sets account ID equal to that static variable, and it increases the value of the static variable. I want to note here that new balance acts as a local variable since it's a parameter, and so anywhere else in here, new balance isn't usable. If down here in this method I try to say new balance equals 2, it would say variable is undeclared. It doesn't have access to the variable because the scope of new balance is only this method. I have another method here, withDrawAll. In withDrawAll, I make a true local variable. I've declared a variable temp to 0.0, and I set the value of this instance variable balance to temp. Finally, one more thing to look at is this main method that's in another class. I would like to note that this main method does not have access to balance, account ID, or number of accounts because those are all private variables. In here, I make a new account local variable, ACC, a local account variable with the balance 100.0. In this case, the 100.0 is an actual parameter, an actual double parameter, which is copied by the formal parameter new balance. So in this case, we have an actual parameter 100.0, and we have a formal parameter new balance, which makes a copy of that and stores an additional copy of 100.0. And then I've called withDrawAll just to demonstrate calling an instance method on a variable ACC. Take a second if you don't understand to look through this and try to determine, based on our list up here, what type of variable everything is, where it's accessible, and what it all means. One last point I want to make about variables and scope and access is what happens if we have multiple variables of the same name. Well, usually that's not allowed, but in some small cases it is. If local and instance variables have the same name, that is allowed, and in that case the local variable takes precedence and is prioritized. So let me give you an example of that. let's say here we had a method public. I guess I don't know why I deleted that. Let's just add a new method. We had a method public void print balance that took a double balance. In this method, all we do is print out balance. And then in here, I want to print out the balance of ACC, and I'm going to input 999.9. So what's going to happen here? Well, you'll note here that we have up here an instance variable balance, but we also have a parameter called balance, which is acting as a local variable. Well, when we print this out, since local variables take precedence over instance variables, this will print out this balance here, which happens to be a copy of 999.9. So this line of code will print out the balance 999.9 rather than the instance variable, which has the value right now of 100. Usually it is bad programming practice to have two variables with the same name, and so that this won't come up, but occasionally it will, and it most often comes up in constructors. So the same thing can happen here if I change this value to balance. This line balance won't function. So what can we do to improve this? Well, we have to use a keyword in Java called the this keyword, and that's my second topic. The this keyword is a special keyword reserved in Java, and it refers to the current object that you are in. So how would this apply here? Well, I want to distinguish between the balance that belongs as the instance variable to the current object and the balance that's been passed as a parameter. And the way that I'm going to do that is I'm going to say this.balance equals balance. This.balance will refer to the instance variable of this specific account and set it equal to the value that's passed in. Similarly, in this print balance method, if I wanted to print out the actual instance variable balance associated with this object, I would say this.balance. This might also come up if, for instance, if we had something like public double compare balances, which took a second account. And if I wanted to return the difference in the two balances, maybe I'd use something like return this.get balance minus other.get balance to distinguish between this and other. There's one other situation in which we need to use the keyword, this keyword, and that's when we need to call a method and pass ourselves. I guess I shouldn't say we. An account, for instance, needs to call a method and pass itself as a parameter to that method. So let's do an example of that. A situation that I thought of in which this might be useful is if every account had associated with it an account holder. So let's say we have an instance variable which is an account holder. Account holder is another class, and we have objects of account holder which represent people. So when I create my account constructor, I'm going to pass in. Actually, let me just pause for a second. In my account constructor, I need to make a new account holder. But not only do I want the account to have access to the account holder, I want to have the account holder to have access to the account. So the account will have an account holder instance variable as we see here. But in addition, the account holder will have an account parameter. So actually, let me delete this real quick to give us some space and just have a constructor. Hopefully you got all that. And let's write our account holder class. So we're going to say public class account holder representing a person, and this account holder class has two things. It has a name of the person and the account that they own. And in the constructor, we take for the constructor, we take a string name, and we take a account, and we set this.name equal name, and this.account equal account. Note my use of the this keyword to differentiate between this name and this name. All right, well, how are we going to accomplish this? Well, let's say my account, when I construct an account, it also constructs an account holder object to serve as its owner. My account object is going to take an owner name as a parameter, and in my account class, I need to make a new account holder. So I'm going to say owner equals new account holder. Well, what does this account holder class need as its input? The account holder class needs two things. It needs a name. Well, that one's easy. The name is going to be owner name right here. And it needs an account reference. It needs to know the account that it owns. Well, the account that this owner owns is the account that I'm currently constructing. So in order to pass that in, all I have to do is pass in this keyword. So now I've made a new account holder that has the name that is specified by owner name, and the account that it owns is this account right here. Now I have successfully created an account which knows about its owner, and an account owner which knows about the account. And to do that, I had to use the this keyword to pass in a reference to the object that I'm currently in. This won't come up often for you, though it does in fact come up in graphics sort of often. But it is worth knowing that if we ever need a direct reference to an account, to the object that we're in, we need to use the this keyword to accomplish that. I know this was a lot, and I hope this video wasn't too confusing, but if it was, please ask me questions about this in class. Remember that we have a couple due dates coming up. Deck and card are due on Monday. Next Friday we have the project, the dice game project due, and then on that Friday we will also have a small quiz on classes and objects. Thanks for listening, and I'll see you guys on Monday.